Welcome everyone to this section of the course devoted to a supervised learning project exercise. Let's get an overview of what to expect. Now we've learned a lot of supervised learning algorithms so far, starting off from linear regression to logistic regression, and then all the way to the tree-based methods we just learned about, including single decision trees, gradient boosting and adaptive boosting, and random forest. And we want to wrap up all these sections and the overview of the tree methods lectures with a supervised learning project. For this project, we're going to be exploring the churn of an internet and telephone provider, including exploratory data analysis, churn cohort analysis, and predictive machine learning. And in case you're not familiar with that term, churn, it essentially stands for someone ending their service. So we want to predict, based off a variety of features of a customer, when will they end their service. So there's three approaches to this project. The first one is to simply load up the dataset, that is the CSV file we provide in the notebook, and create a predictive model, where you're just going to create any visualizations you find useful to understand the data, and then you'll use any supervised learning model you prefer. So essentially you're just going to run the first three cells in the notebook, or create a brand new notebook, and just have at it. Given everything you've learned so far, you should be able to make a pretty good predictive supervised learning model, and you can choose anything from logistic regression to the tree-based methods, support vector machines, etc. So that's the first approach, essentially completely hands-off from us. You just take the data and have at it. Now, the second approach is probably the more standard approach that goes in line with everything else we've covered, and it's to use the notebook as a guide and complete the tasks in the notebook. And the tasks follow in the form of first reading in the dataset, running your imports, having exploratory data analysis, and then we have kind of a quick turnaround into churn and cohort analysis. So we describe the tasks there, as well as the visualizations to create. And then we'll move on to predictive tree-based models. Now, the notebook guide is only going to explore tree-based models instead of things like support vector machines or logistic regression. That's not to say those models may not work, it's just we really want to focus on tree-based methods since we didn't have an exercise in any of those sections. Now, the third and final approach is to just relax and treat this as a code along. So if you want, skip straight to the solutions notebook and video and follow along to see maybe where you would approach the data differently as we guide you through the tasks in the notebook. So you could go straight to the solutions and then kind of follow along, pause it, maybe explore your own visualizations or your own ideas, and then go back to solutions and kind of take it that way. But either way, whatever you decide to do is totally fine, whether you want to just take it all on your own, or 2, follow along with the tasks, or 3, just go straight to the solutions. Either way is okay. We're going to jump to the exercise project notebook and check it out. So let me head over there now. Okay, here I am at the notebook. It's under the 17 Supervised Learning Capstone project called Soup Learning Capstone Tree Methods. Now the reason we call it Tree Methods Focus is because if you follow the tasks in the notebook, you will only explore tree-based methods, comparing a single decision tree to a random forest to boosting methods. So keep that in mind. There is a focus on tree methods, but obviously you can explore any other supervised learning methods you want to check out. So again, there's different ways to approach the notebook. Number 1 is kind of just read in the data and do whatever you want. Number 2, use this notebook as a general guide, which I'm going to go through right now, not the solutions, just the general tasks and visualizations. Or 3, skip straight to the solutions, kind of take a more relaxed approach and just kind of code along with us. All right. So part 0 is just the imports and read in the data. This is already filled out for you. A couple of imports, read in the data. It's called telco customer churn.csv, and then check out the data here. So you notice there's a bunch of features. There's gender, senior citizen, partner, dependents, whether or not they have phone service, whether or not they have multiple lines, etc. So you can check that all out and kind of explore this on your own. Pretty much all of them are self-explanatory. The class we're actually trying to predict is whether or not the person churned, so whether or not they discontinued the service. So you keep scrolling down here. There's a quick data check, so this is part 1. We'll ask you to do things like use .info, .describe, check out what's available, and then we quickly move into part 2, which is just exploratory data analysis, starting with a general feature exploration. What we're going to do is have you confirm that there's no missing data, which there isn't. You should be able to confirm that. And then we ask you to basically create a bunch of plots here. So display the balance of the class labels. You should see most people do not churn, but there are some people that do churn. Not terribly imbalanced here. There's kind of maybe a 3-to-1 ratio of these labels. Something to note here is that while we do recommend you code in this cell, if you check out this cell, it's actually a markdown cell, And if you double click on it, you'll notice it's just pointing to a PNG file that's in the same folder. So if you opened up the folder, you probably notice a bunch of PNG files. Those are just the actual files that are linked to in the markdown cell. So if I run this cell, it will just put in the image there for me. So again, if you accidentally double click on one of these images, it'll show you the markdown cell. Don't worry, you can always just run this markdown cell and it'll display that PNG image directly in the notebook. And this is mainly to avoid the issue of you accidentally running the cell above it and missing what the visualization looks like. Okay, so we just basically ask you to show a bunch of plots here. The distribution of the total charges between the churn categories. Then we ask you to create some more advanced box plots. Ask you to create a bar plot with some specific features that we list out here for you, kind of as a convenience metric. And then you scroll down here, we're essentially asking you to figure out the correlations between them and then plot those out. So we have feature correlation to yes churn. Probably have to make some dummy variables to check that out, kind of a hint there. Then part 3, we're going to really focus on churn analysis. So churn analysis often has to do with cohort analysis, where you group or segment together customers based on how long their tenure is. So maybe you have customers that have been on the service from 0 to 12 months, and another set of customers that have been on service maybe 12 months to 48 months, etc. So later on we're going to segment these customers, but we first ask you to describe the actual distribution of the tenure column. So you'll be creating a histogram distribution of tenure. You'll notice there's either a lot of people that have very little tenure, maybe like 1 or 2 months, and then the second most popular category is to have a lot of tenure over 70 months, essentially people that haven't unenrolled yet or haven't churned yet. And then you have everyone in between. So we want you to then split this out based off cat plot and Seaborn to create a plot that looks like this. And you may need to review the Seaborn documentation on how to do this. It's .catplot, so go ahead and check out that hint. But notice here I have rows and columns depending on whether or not someone churned and what their contract type was. Were they month to month? Were they 1 year? Were they 2 years? Etc. And you'll notice that first row is people who did not churn, and then this second row is people that did churn. And so you'll notice someone that has a month-to-month contract, there's a lot more churn there, versus someone that has a 2-year contract, there's very little churn, and there's a lot more churn on things like a month-to-month contract, which kind of makes sense. If you sign up for something month-to-month, you're likely to end your service versus signing up for 2 years. Okay, so we'll continue down here. Where you're going to end up displaying a scatter plot of total charges versus monthly charges, color them by churn, whether or not they churned. And then this is where we get a little more complicated on creating cohorts based on tenure. So what we want you to end up doing is first treat each tenure length, which is 1, 2, 3 months, 4 months, etc., as its own cohort. So you're essentially going to group everything together based off that particular unique tenure. So group everyone by the 1-month tenure, the 2-month tenure, the 3-month tenure, etc. And you'll have to figure out how to do this. This part is actually quite tricky. So keep in mind you may kind of be scratching your head a little bit. I know I was taking a while to think of the best way to do this. But essentially what we want you to do is figure out how to create this series where you have tenures of all the unique tenure values. So everyone that had a tenure of 1 month, everyone that had a tenure of 2 months, etc. And then notice what I have here is a value. And this value represents the churn rate. So the percentage of people that had yes churn over the total number of people. So after 1 month, 61.99% of people churned in that cohort of just being at 1 month. Then the people that had a tenure of 2 months, 51% of those people churned. Then the people that had a tenure of 3 months, 47% of those people churned, etc. So it makes sense that this value is slowly going down because the people that have been on the service the longest, 69 months, 70 months, 71 months, very likely that if you're on the service that long, you're probably not churning that much anymore, especially because you're probably just in need of this service or you have a very long contract with the provider. So keep that in mind. That's the tenure and cohort analysis. And then what we're later going to do is have you kind of plot this out, the churn percentage per cohort there, where every single tenure value is treated as a cohort. Now, this is not typical that you treat each unique tenure value as a cohort. Once you're done with that, what we're going to have you do is create broader cohort groups or more standardized cohort groups. Instead of treating each monthly tenure as a unique cohort, instead we want you to group people together based off their tenure values. So essentially you'll have 4 cohorts. The first cohort are going to be people that have a tenure between 0 and 12 months. So you'll gather all those people together. Then the next cohort is going to be people that have between 12 and 24 months of service. Next cohort is between 24 and 48 months, and then everyone else will be grouped into a cohort called over 48 months. And so you're going to create a new column based off the tenure column. So for example, we have the original tenure column. This person has had service for 1 month, so the cohort they are in are 0 to 12 months. This person has service for 34 months, so they are in the cohort of between 24 and 48 months. And you're going to do this, so hopefully you can figure out how to use an apply function to do that. Next, you'll create a scatter plot of total charges versus monthly charts, but now you're going to use tenure cohort, and you're going to see this kind of interesting behavior. So take your time to understand what this is actually representing of total charges versus monthly charges colored by the cohorts. And it should make sense to you that kind of on the bottom here are the shorter cohorts, and then on top are the longer ones over 48 months. Makes sense that the longer you've been on service, the more total charges and monthly charges you've had. So then we're going to scroll down here. You'll create a count plot showing the churn count per cohort. Another nice visualization here to see that you're at most risk of churning towards the 0 to 12 months versus over 48 months. Most people don't churn after that. Then what we're going to do here is create a grid of count plots showing counts per tenure cohort separated out by the contract type. Who's on month to month, who's on 1 year, who's on a contract of 2 year. Makes a lot of sense that contract is equal to 2 year has a very large value of over 48 months because most people on a 2-year contract are probably going to actually spend more than that time. Versus month to month, it's unlikely you go month to month for over 48 months, which is why these bars, the overall counts, are lower, but they do still exist. After that, we move on to predictive modeling. We'll first have you perform a single decision tree. You'll do your train test split, hold out 10% of the data, and we just have you do kind of a bunch of things here. Create a single decision tree model, evaluate performance metrics, including a classification report, plot your confusion matrix, so you can use plot confusion matrix for that. And then we also want you to calculate feature importances from the decision tree. After that, if you want, you can plot your tree. You should note though that if you don't do any other parameter searches for your tree, depending on your pruning, your tree could be really, really large given the amount of features. So it may crash your notebook if you have plot tree. So keep that in mind. If you have a really huge decision tree, it may crash. And you can always do a grid search for optimal hyperparameters. So we should expect you to get some performance, kind of around 80% accuracy, and you'll get lower precision and recall for the yes class versus the no class. So keep that in mind. You can check out our performance here. We do not do any complex grid searches in the notebook, so you can feel free to do that if you want, but that's just a single decision tree. Create a, let me scroll down here, create a feature importance here. So you notice tenure, very strong feature, kind of makes sense. And then you're going to scroll down here. Here's my decision tree that I use. So you notice kind of the depth that I got this performance with. It's about a depth of 6. And if you want, you can then kind of zoom in on this to see what the actual features are being split on. After that, you'll move on to a random forest. Same idea. Notice here that random forest doesn't actually improve that much. And depending on your situation and hyperparameters, it can perform slightly worse or slightly better than the single decision tree, which is kind of interesting. And then after that, you'll move on to boosted trees. And in our personal experience, as far as base hyperparameter choices, we got boosted trees to perform the best. And so we got slightly better performance. And this is kind of a more realistic example of the differences between the tree methods. If you're dealing with a complicated data set, it's very likely that you don't actually see a huge jump in performance moving from one tree-based method to the other. It's more trying to tweak to squeeze out just a little bit more performance in terms of single percentage points. It's usually not by leaps and bounds. If you do have leaps and bounds, that's kind of indicative of switching over to a model that operates on another methodology, such as support vector machines or logistic regression. So I encourage you to also check out those other models if you want to explore them. So then we have the boosted trees, and overall, after you analyze your results, which model performed best for you? With the base models, we got best performance with AdaBoost classifier, but no, we don't really do any grid searchings, and most models actually perform kind of around the same. So keep that in mind. Okay, that's my giant overview of the notebook. If you have any questions as you go along, feel free to post to the forums. I'll see you at the next lecture where we begin going over the solutions.